So in terms of transactional systems, what can we call it as a transaction? What are the things we do, like withdrawing the money from ATM or booking a ticket at reservation counter, online reservation counter? All these things are called as transactions. The service points, the ATM is a service point, the bank branch is a service point, reservation counter or the website is a service point. So after the request is given to them, the service will be provided to us with a service request number, right? So which will call it as transaction reference number. So once this transaction is done, this transaction details will be preserved. So whenever you take out a mini statement from the bank ATM, you'll be seeing the last 10 transactions, right? If you log in into your internet account, bank account, and if you see, it will also have the unique transaction number in the mini statement of your account, right? So what is the necessity for preserving them, and why it is only storing the last 10 transactions? Okay, so the transactional systems which we are, what are the transactions we are doing? After the end of the day, the transactions that were done at those source systems will be moved to a centralized system, which will, or the centralized database, which is called as a data warehouse. Okay, so it's not, it doesn't mean like on every day-to-day basis the data from the source systems will be transferred to the centralized database. It depends on the environment. Sometimes there could be a batch load that happens on hourly basis or daily basis. Okay, it depends on the environment, and sometimes there could be a data transfer from source to the centralized database on a couple of minute basis, which we'll call it as near real-time data warehouse, means the active data warehouse. For mission critical applications, all these things, there will be a immediate feed that will be continuously loading the data into the centralized warehouse. Based on that, it will prepare the trend analysis. So what is the necessity for going for a centralized database, which we'll call it as a data warehouse? Okay, so the need for going for a centralized database, which we are calling for a data warehouse, is whenever you want to go ahead for a profitable decision, like you have a bank branch in a certain area and you want to go for a new bank branch in a new area. So what the bank will look at, how many customers are coming to this particular branch from the new area which we are planning to set up a new branch. So how many customers are coming from that area? What is the volume of the transactions of the customers that were doing the transactions there? What is the amount of the transactions they are doing? So based on that, they will set up either a single desk branch or a mini branch or a major branch or only a ATM machine. It depends on the volume of the transactions they were doing in the surrounding branches. So what they are going to do and what factor they are going to analyze means they are going to depend on the data that was there in their centralized system. Okay, so for anything we'll be relying on the data. So this data which they are relying on and which is there in the data warehouse, is they are not going to rely on the data which is there of the last month or last 2 months. They may depend on the data which is there from years. Okay, you can't go ahead and take the decision based on the data of 1 month or 2 months or 3 months. They will analyze the patterns in the data. Okay, they will analyze the patterns in the data which are recurring in terms of transactions from last 2 years, 3 years or 4 years, which is called as trend analysis. Okay, which they will call as trend analysis. They will identify the trends in terms of the deposits, in terms of the withdrawals, in terms of the forex change. All these things they will analyze on which area they are getting the transactions. Based on that, they will set up the branch. Rajesh, you are getting right?
Yes, yes, Amit.
Okay. So based on this, they will analyze this. So in terms of whatever be the transactions that were occurring in the transactional systems or the live areas, which we'll call it as source systems, means in one word you can say where you are getting the request done is called as a service center, or this service center is nothing but our source system. All these are the source systems, and the data from these systems will be archived on a regular interval basis and will be moved to the centralized database called warehouse. Okay, which is an analytical system. The source systems are always the transactional systems. What is the main difference between a transactional system and analytical system? In terms of the transactional systems, you'll be processing a very few records, roughly hundreds of records, where the transaction lifetime is going to be couple of seconds. Whereas in case of an analytical system, you are going to process millions and billions of records. Okay? Whereas in case of transactional system, you are going to process millions and billions of records where it may run for hours. Okay? So in this particular case, you'll be expecting your database to work in a faster manner. Okay? You'll be expecting the output to be given to the user in a predictable amount of time or in a certain faster manner. Okay, so there comes the Teradata database in terms of the analytical window. Okay, so the reason why Teradata is mainly used for analytical processing systems, OLAP environments, or you can also say it as for data warehousing environments, is because of its architecture, because of the parallel processing capability it is having. Okay, because of the parallel processing capability it is having. So in terms of the Teradata architecture, you can say like it is going to have three basic components. One is called as PE, Parsing Engine. The other is the message parsing layer, which we'll also call it as Binet. And the third one is going to be the component called AMP, Access Module Process. Okay. Third one is going to be the Access Module Process. So these are the three primary components in Teradata architecture. So here both the parsing engine and AMPs in Teradata system are called as vprocs. Both of them are called as vprocs, and why both of them being having different entities, why they are called as vprocs. Parsing engine is also called as a vproc and AMP is also called as a vproc. Okay, so why these two entities are called with the same name is the question. So in terms of the requests that were served by the users, the parsing engine is the one that defines how to process the user request. You are firing a query saying like select star from employee table. So what it does mean? You need to retrieve all the data from the employee table. So how the request should be processed in the backend by the database. All these things will be prepared by the parsing engine. Okay. Parsing engine is the one that dictates the things like this is the way how the things need to be done on the system. Okay. The way the query need to be retrieved will be defined. The steps will be defined by the parsing engine. Okay. And AMP will follow those steps that were given by the parsing engine. So in a company, your boss and employee will be both boss and the team member, both are the employees of the company. So where is the difference that is coming up? Boss is the one who is the master, who is having the blueprint and visualizes the blueprint and how to do out the tasks, how to coordinate, how to do the things in a sequential manner or in a predefined manner. All these things will be defined by the boss. Whereas the team member will follow the given blueprint and instructions given by the boss, and he will complete the task as per the given guidelines, right? Similar is the way here. Being both the vprocs, parsing engine is the master vproc, or you can also call it as the master AMP that dictates the things how to process the request with. Okay. Parsing engine is the one which is also called as a master vproc or master vproc, which will dictate the things in order to how to retrieve the data from the system. Okay. And AMPs are the ones that are not the standalone components, they are the dependent systems. Okay. AMPs are the dependent systems and they are dependent on the parsing engine. They are dependent on the parsing engine for the instructions regarding how to proceed with the request. They don't have the capability to think on their own. Okay, they don't have the capability to think on their own. They will get the instructions from the PE and they will act only as per the instructions that were provided by the parsing engine. They will follow in the same order as the parsing engine has suggested for them. Okay, they will work as per the instructions. And what is this message parsing layer meant for, or which we are calling as binary? Whatever be the instructions that were sent by the parsing engine to the AMPs in the system will be delivered. The instructions that were sent out by the parsing engine will be delivered to the AMPs in the system by means of this binary. So all the communication in Teradata system, okay, all the communication in the Teradata system will be carried out by this message parsing layer. Whether it can be a communication of one-to-one AMP, means sending the instructions to only one AMP in the system, or to a subset of AMPs in the system, or to all the AMPs in the system. Any kind of communication, which we will call in general terminology like one-to-one communication, multicast, or broadcast. Any type of protocol will be supported by the BiNet in the system. Clear? Rajesh? Is it clear till this point?
Yes, clear.
Okay. So being these three components, AMPs are, you can see here, AMPs are connected to some cylindrical component kind of structures here, right? These cylindrical structures are called as virtual disks. Okay, we'll generally call them as V disks, virtual disks. So in general, the disk could be physical in nature, right? But I am saying here it is a virtual disk. So why it is not called as a physical disk? If I am saying it as a virtual disk where the data is going to reside, the data will be stored on a physical component, not on a virtual component, right? If it is stored on a virtual component, it's not going to be a data that is going to be a permanent in nature, right or wrong? If I'm saying the data is getting stored in a virtual disk, means that the data that is getting stored in that is not going to be a permanent one in nature, right? The
Yeah.
data will be generally stored on the permanent area, which we'll call it as a physical disk. But I'm calling it as a virtual disk here. So what is called as a virtual disk? In my laptop, I have a hard disk of 1 terabyte, let's say, and I have divided it into 4 partitions called drive A, drive B, drive C, drive D. Okay, I have divided into 4 equal partitions: drive A, drive B, drive C, drive D, and each drive has got a chunk of 250 GB of space on the physical disk. So are these partitions going to be physical in nature or logical in nature? Any guess?
So logical.
Logical partitions, right? Let's say now I am going to
Yeah.
copy a file of 250.01 GB of size file from my external hard disk to drive A. Okay, I'm going to copy a file of size 250.01 GB of file from my external hard disk to drive A. Will it be accommodated in drive A?
No.
It's a matter of
No, it
0.01
won't.
GB or it's a matter of 1 KB. Will it get accommodated from drive B or drive C or drive D?
No.
It's not going to
No,
be
it won't.
accommodated, but it's only a logical partition, right? It's not a physical partition, right?
Yeah, but uh,
Even though it is a logical partition, okay, it is meant like this particular, starting from this byte to this byte, this is the space reserved for drive A. So it's not going to be increased, not even by a single byte, right? So it doesn't accommodate. So that copying will fail, saying that free up some files, right? So here the portion of the space on 1 terabyte hard disk, that whatever with the 250 GB of space that was assigned for drive A is a logical partition, right? Similar is the case in Teradata system. It will have a big amount of physical space. Out of the available total physical space, all the space will be equally allocated to all the amps in the system. Let's say you have 1 terabyte of space and you have 4 amps in your system. That 1 terabyte by 4, which will be roughly equal to 250 GB of space. So each amp is allocated with 250 GB of space. Total space available divided by the total number of amps in the system is going to be the space per amp space allocated to each of the amp in the Teradata system. Okay, per amp space is the one we'll call it as. Virtual disk is nothing but the total amount of space allocated to each of the amp in the system, or you can also call it as, in theoretical, the logical amount of space that was reserved on the physical disk for each of the amp in the system. Okay, the logical portion of the space that was allocated to an amp on the system on a physical disk is called as a virtual disk. So whatever be the 250 GB portion that it was allocated to it on the 1 terabyte hard disk, which we are calling it as param space, that is nothing but the V disk. Okay, virtual disk. So whatever be the space, the 250 GB allocated to AMP1, the whatever be the space 250 GB allocated to AMP2, like that till AMP4, they will not share with the other AMPs in the system. Okay, whatever be the 250 GB of space allocated to AMP1 will not be shared with the rest of the AMPs in the system, and whatever be the space allocated to AMP2, the 250 GB, it will not share with the rest of the AMPs in the system. Like that, they will not share the space across them or between them in the Teradata system, even though they are on the same system. That is the reason why it is called as a shared nothing architecture. So whenever you create a table and whenever you load the data into the table, the data will be stored across all the AMPs in the system. A portion of the table's data will be stored on each of the AMPs in the system. So whatever be the portion of the data that was stored on AMP1's local vdisk or AMP1's vdisk will not be shared with the rest of the AMPs in the system, whether it can be a space resource or whether it can be a data resource. Nothing can be shared with between them. Means AMP1 is not going to share the resource under it with the rest of the AMPs in the system. Similar is the case with AMP-N. So that is the reason why it is called as a shared nothing architecture. So when it comes to work, AMP1 will work only on its allocated virtual disk area. It's not going to interfere in other AMP's vdisk portion. Okay, it's going to work only in its vdisk portion. Clear? Rajesh, any question?
No, so far it's fine.
Okay. So they will work only in their dedicated virtual disk area. So if you say like these are the basic components in Teradata architecture. If I go more deeper into this Teradata architecture, so whatever be the virtual PEs and AMPs in Teradata system, they will be enhanced whenever you add a new node into your existing architecture. So in terms of Teradata system, whatever be the hard disk, as I told, like let's say I have 1 terabyte hard disk and I have 4 AMPs in my system, right? So when I'm done with my space on my Teradata system of this 1 terabyte, okay, when I am saying like the space on this Teradata system, just a second, Rajesh, I'm getting a call. Whatever be the 1 terabyte we are saying, right? If it is done completely, if the space is completely used up, okay? If the space is completely used up, what is the next thing we need to do? Here it is just like a Teradata system is just like a pre-configured system or whatever be the, let's say the Moto G, take the example of Moto G phone. It is coming up with an inbuilt storage of 8 GB, right? Or 16 GB. You don't have the capability of keeping a data card or the storage card, right? So whatever with the 16 GB you are having, if it is done, it's done, right? Similarly here, whatever with the 1 terabyte system you are having, whatever be the 1 terabyte of space you are having on the system, if you are done or you are about to reach the saturation point, you are about to reach the saturation in terms of the disk space. You don't have the capability to expand only the memory in Teradata system. Okay, if you are done with the space on the system, it's done. So that is the reason why the space should be precisely used on Teradata system. So you can't go and ask a Unix admin to add a new hard disk and give out the mount point to you like the traditional databases we are having in the market. Okay, so if you are having that feature of having an extra hard disk and getting it mounted on your server, okay, Whenever you are adding a new hard disk, let's say if it is there, earlier you are having 1 terabyte of space, now you are adding a new hard disk of another 1 terabyte. What is the total space now? It is going to be 2 terabyte, right? But whatever be the processing capability that you are having earlier, which is going to process the 1 terabyte of space, is now going to work on the 2 terabyte of space, including the new one, right or wrong? You have added only the hard disk, but you have not added the processing capability, right? So whatever be the processing speed that you have earlier is now going to continue the same, which is going to work on 2 terabyte of space, right? So in that case, you have enhanced only the memory, you have not enhanced the processing capability. So there could be a degradation in terms of the performance. Is it an acceptable thing? Enhancing the space, causing it a performance issue is an acceptable thing? Definitely not, right?
Yeah.
So what happens in Teradata system is there is no such concept of adding the hard disk. So whenever you are done with the, or whenever you are going to get saturated with the disk space, you will be added with a node, Teradata node. In terms of Teradata, we will be having some nodes. What is a node means? Whatever be the collection of these AMs and PEs in Teradata system is called as a node. Okay. A group of PEs and AMs with a certain amount of hard disk space is called as a node. If you are having only one node in your system, it is called as a SMP system, symmetric multiprocessing system. If you are having more than one node, it is called as a MPP system, massively parallel processed system. Okay. MPP means massively parallel processed system. So whenever you are done with the space on the system, you'll be getting a new node, and you'll be integrating this new node to your existing node. Means you are having an SMP system. You got a new SMP
Uh,
system, and it will be.
Excuse me. Like you're writing something or in notepad
No,
like
I'm
that?
just visualizing on the slide itself.
Okay. Okay, fine.
This is not actually, this is the thing that happens in the backend. I'm just telling it for his purpose, information purpose. Okay. If you see here, you can see a component box kind of system, right? This is the SMP system, which we'll call it as node. Inside this box kind of structure itself, you'll be having the P's and AMs in the system. Okay. So if your business is in starting phase, you can start with your Teradata system with a single node. Okay. You can start your system with a single node. As your business grows, as the data grows, you can keep on adding the SMP nodes. It's just like a plug and play architecture, and this integration of new node to your existing node will be done by the Teradata Corporation itself. It's not going to be done by you or your DBA or the networks or the system admin at your place. It's going to be done by the Teradata Corporation itself. Okay, it's a proprietary software, so everything will be in the control of Teradata Corporation people. Okay, so even if your DBA is working on it, he is bounded to only use the database. He is not allowed to touch the internals on the Teradata system. Okay, any hardware or software issues will be handled by the Teradata Corporation people. Only being a DBA, he is meant for only managing the database. So whenever you are adding a SMP node to another SMP node, means you are adding a node to an existing node in your Teradata system. Whatever be the 1 terabyte of space that it was earlier having will be added with another 1 terabyte. So now the space is enhanced by another 1 terabyte. It's doubled. So what about the case of the performance? Is it going to degrade? It's just like adding one CPU with another CPU. For a system, you are already having a CPU, and if you are bundling that CPU with another CPU, what will happen? If you are adding one CPU, another CPU to a existing CPU, means what will happen? What does it mean? It means like to an existing hard disk, you are adding another hard disk, right? For existing processor, you are adding another new processor, right? So in terms of that, you are not only enhancing your disk space capability, or also enhancing the processing capability, right? Whenever you are adding a CPU, new CPU to an existing CPU, means you are not only adding the extra hard disk, you are also adding the extra RAM, all these components, right? So it means like the same here. Whenever you are adding a new node to an existing node in Teradata system, it's not only going to enhance the disk space, it is also enhancing the processing capabilities. Whenever you add a new node to an existing node, it also increases the number of amps and PEs in the system. See, the amps and PEs are nothing but are also called as the units of parallelism. Means you are adding more workers to your work. If you are adding a new node, means you are also enhancing the number of P's and amps, which means that you are also adding more another boss and some more team members to your project, which will complete your request in a more short span of time. Okay. Whenever you add a new node, it will also enhance the communication layer, which we are calling as a binet. So whenever you add a new node to your existing architecture, it will enhance the system in every perspective. It could be in terms of the space, it could be in terms of the communication channel, it could be in terms of the processing capabilities. So that is why the Teradata system is called as a linearly scalable system. We have seen two things till now. One is shared nothing architecture. The other one is linearly processing system. Any questions still in these 2 points, Rajesh?
No, Chaitanya, so far good.
Okay. In the same slide, you can see some rectangular box kind of things, which are mentioned as DAC, disk array controllers. What are these disk array controllers? These are the physical disks. These are the stand-like structures where the physical disks will reside. Okay, these are the physical. These are the stand-like structures where the physical disks will reside. All these physical disks or the disk array controllers will be connected to all the nodes in the system. Okay, a group of disks will be connected to each of the amp in the system. Those group of the disks in the disk array controller are called as the virtual disk area for each of the amp in the system. So if you see here, you can see two binets here. One is in the blue color and other is in the yellow color in the Teradata system. Okay, so why we are having two binets in our Teradata system? Does it mean like is it having another binet? Means yes, you are going to have two binets in your Teradata system. The binet is not only the communication medium across between the amps and PEs in the system, but it is also the communication carrying system across the nodes also. From one node to another node also the communication will be derived by the binet itself. So we will be having two binaries in Teradata system. One is called binet 0, other is called binet 1. So what is the necessity of having two binets in the system is the question. The reason of having two binets is, let's say you're traveling from one area to another area in Bangalore. That particular route which used to move on a day-to-day basis is blocked. So what will happen? You have to postpone your plan to move to that area, to travel to that area, right? If you don't have any other alternate path. Similarly, in terms of Teradata system, when if the route that it is carrying out the signals is blocked, the communication channel is blocked, then the entire system would be halt, right? The entire system will be halted. In that particular case, in terms of a load sharing mechanism, as an alternate path to carry out the communication, will be having another binet in the system. Or let's say the network traffic is huge on one of the binet, then in that case also the traffic will be rerouted through the other binet. So who is the person that is going to drive this communication process in terms of rerouting the data from one binet or the other binet in terms of huge network traffic? Or who is going to suggest that, or who is going to decide that this binet should drive the communication because the other binet is going to be is dead or is having some trouble? In that case, means it is the binet itself will reconfigure the network traffic. It's not going to be the case of with the developer, or it's not going to be the case with the DBA. It will be driven by the binet itself. Binet is a communication mechanism that is having the intelligent network. When the network is having huge amount of traffic as a load sharing mechanism, it will reroute the traffic through the other binet in the system. So it will act as a load sharing mechanism. When there is a congestion in any of the binet also, then it will reroute the traffic through the other binet. Rather than going for a system halt, continuing with a degradation of performance continuing with degradation in performance will be an acceptable scenario, right? So it will reroute the traffic through the binet until the binet congestion is cleared. So binet is having the capability to troubleshoot on its own, to reroute the traffic based on the network bandwidth. So that is the reason why you need to have, why the system will have a dual redundancy with respect to the binet in Teradata system. Okay. So on the whole, if you see, you will be having for a set of amps, you will be having a parsing engine and a dual redundancy binet in your Teradata system. Okay. So going a bit more deeper into the parsing engine, whenever I said like the instruction, whenever a user fires a query, the parsing engine is the one that is going to provide the instructions how to retrieve the data from the table or insert the data into the table. That is the thing I have mentioned. So if parsing engine is providing the instructions, means there could be some data that it should rely on, right? Without having the data, how it is going to provide the instructions is the question. On what factors the parsing engine is providing the instructions, on what basis it is providing the instructions is the question. There is a factor called, in terms of providing the instruction, parsing engine will rely on the data. That data is called as data demographics. Based on the data demographics of the system, Parsing Engine will prepare the instructions of how to retrieve the data from the system. If I'm saying data demographics, what are these data demographics? Is the question that will again come up into mind. Data demographics are nothing but what is the size of the table, what are the columns that were there in the table, how many total records are there in that particular table. Out of the total records, how many are the duplicated records? And what were the indexes that were there on the table? These are the things that will be called as data demographics. In general, what a table will have? Rows and columns, right or wrong? What is a table? Nothing but collection of records is called as a table, right? A table is nothing but a set of columns with certain data types, which we will call it as a record, and collection of these records is nothing but organized into a structure called a table, right?
Yeah.
So it will identify like what are the columns in the table, what are the data types and the indexes. Based on that data demographics, it will prepare the plan. Not only on the data demographics, it will also consider the network traffic and the model of CPU you are using. Means the Teradata model, server model you are using. Based on that only it will calculate the time, how much time it is going to identify in terms of processing the request. All these things will be considered as part of the instructions. So have you ever heard of the word optimizer? Rajesh, have you ever heard of the word
Yeah, little bit.
optimizer?
Yeah, little bit. Yeah.
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 What is the general meaning of optimizing?
So in case if there is any
No,
like
forget about the
time
technical
table,
meaning. Just
time table.
tell time saving. Not
Yeah.
only the time saving, optimize means save the possible extent, right?
Yeah.
Save the resources. It could be anything, right? Save the
Yeah.
resources and use it in a profitable manner. It is nothing but the optimizing,
Correct.
right? So whenever you are firing a query, you have connected to a database and you fired a query like your intention is to retrieve the data from employee table. So what could be the possible query you will fire? Select star from employee table,
Yeah.
right? So
Yeah.
what is the thing that you are going to look at? First thing is when I'm going to execute the query, first thing I'll check is are there any syntactical issues? Rather than typing SELECT, I am typing it as SLECT. Will it allow?
No.
If there are any grammatical or syntactical issues, it's not going to allow.
Correct.
And another thing is you need to have the access to the employee table. That is the thing. If you are not
Correct.
having access to the employee table, it will not allow you to execute the query, right?
Correct.
So whenever you are firing the query, the parsing engine will first analyze whether there are any syntactical issues in the query. If there are no syntactical issues, then it will check for the accessibility of that particular table by the user. The query is syntactically correct and user is having proper access to that particular table. Okay, both are available. Now the next level is preparing the steps in order to get the data from the table. You are traveling from city A to city B. There are n possible combinations, n possible routes to reach from city A to city B. So which route you will choose? Route 1 will take
Whichever.
you to city B in 10 minutes or 30 minutes. Route 2 will take you to city B in 40 minutes. and route C is going to take you to city B in 60 minutes, 30, 40, 60. So which route you are going to choose?
Okay.
Route 1, which is
Yeah.
going to take you in 30 minutes, right?
Yeah.
But whatever be the route you are trying to choose, route 1, which is going to take you in 30 minutes, all these are based on ideal traffic conditions. The road is empty, you can reach over to city B in 30 minutes. But today, the road is fully packed. Still, you want to go ahead with route 1. So, will you able to reach in 30 minutes?
No.
It will take some extra amount of time because the road is fully occupied. So, if you are planning to go with route B, it is still in ideal condition. So, you can reach over in 40 minutes. So, it depends on the traffic conditions. Similarly, whenever a request is getting executed, it also depends on the current network traffic. How many users are connected to the system and what is the current network traffic on the bynet. Based on this also the estimate will change. So which route to choose? It will analyze like what are the possible combinations that I have in terms of retrieving the data from an employee table. It will analyze all the possible combinations and it will find out the best combination in where I can retrieve the data in a profitable way. The profitable way in system means is nothing but the time, right?
Yeah.
The profitable factor in terms of system is nothing but the time, processing time. If you are saving the processing time means you are also going to save the CPU, cost of CPU, right? CPU usage, right? Similarly, in terms of whenever the system is retrieving the data, it's going to identify the way that it is going to retrieve the data in a fastest manner, means in a short span of time, as all the optimizers nowadays are the cost based optimizers, cost in terms of system time. So it will prepare all the plans. If I'm going with the route 1, it is going to take 30 minutes, but because of current traffic conditions, it's going to take me 45 minutes. If I am going through route B, which is going to take 40 minutes and still the route is not occupied by the traffic, so I'm going to choose route B because as per the traffic conditions, now I can travel in this particular route in 40 minutes rather than the regular route which should take 30 minutes. Because of current traffic, it's going to take 45 minutes. Okay, based on that it will prepare the plan. So based out of n number of possibilities, it will prepare a best possible case, and that possible case is the set of instructions given to the AMP in the system. Okay, so whatever be the steps we have discussed, in the first step it is checking for the syntactical issues and accessibility. In a PE, it will undergo three phases. A query will undergo three phases. First phase is the parsing phase, where it will check for the syntactical issues of the query. Okay. In the parsing phase, which is the phase 1 in parsing engine, it will identify the syntactical issues. Are there any syntactical issues in the query? Whatever be the select star from EMP, whatever be the query, this query you are firing is a high level language which is in human readable format. It can't be understandable by the system, right? The system cannot understand the third generation or fourth generation language that can be readable by the user, right? So how the system is going to identify this select star from employee table query? It is going to break down the query, select into one keyword star, which is a wildcard character, into another token. So it's going to break down the query into pieces, which are called as tokens. Based on this token mechanism, it will analyze the query and it will convert internally into the machine understandable format. Okay. So it will analyze the syntactical issues in the parsing phase. And it will also check whether the user is having access in the parsing phase itself. In the second phase, the optimizer is the one that is going to prepare the plan. Plan is nothing but the sequential steps that need to be followed by the AMS in the system. So it need to devise the steps. AMS does not have the capability to think like this is the first step, this is the second step. The numbering of the steps will also be done by the parsing engine. Okay. So optimizer is going to consider the data demographics and it's going to identify the possible combinations. Means these are the n number of ways that I can retrieve the data from employee table. Based on that, it will analyze the data and it will prepare the plans. As an optimizer is a cost-based one, it's going to pull out the best plan based on the less amount of time how the request could be processed. Okay. Based on the time it is forecasting, based on that it will prepare a best explain plan. Nothing to worry, I'll discuss and I'll show you the explain plan in the next session. Okay. How these particular demographics will be prepared, how this sequential thing is happening. We'll see it in practical. What is the command that was involved in preparing what is the command that we'll be using to get the explain plan? We'll see in the next session. Okay. How the steps are sequenced in Teradata system. How the parsing engine is sequencing the steps. How it is forecasting the steps, that we'll see in practical in tomorrow's session. Okay. Based on these steps, the optimizer has prepared, those will be given to the AMS in the system. So these steps will be sent out to the AMS by net. Okay. So we will see those things in practical in tomorrow's session. How these steps are sequenced. We'll see it on SQL Assistant tool and what is the command that is associated to get that explain plan. The steps are called as explain plan steps or execution plan steps. We'll see them in detail. Okay. Rajesh? Hello?
Hello.
Yeah.
Can
Any
you hear me?
questions?
No,
Yeah.
no. It's all
Okay.
good for
We'll
now.
stop it here for today and tomorrow I'll show you the explain plan, how to analyze that explain plan, in what steps. We'll go through in a not in a detailed manner. We'll see on a high level overview with respect to explain how the steps are getting delivered to the AMS in the system. Okay.
Yeah, sure.
And one more thing, Rajesh, is it this is the only time convenient for you, or will it be okay to have the session in the evening time also?
Actually, Chaitanya, my anytime before 10 or after 9:30 would be fine for me.
In the
In
morning
between
time.
that, no. Morning 10 a.m. to night 9:30. In between this, I'll be in office. So anytime in the morning before 10 is fine for me, and in the evening after 9:30 is fine for me.
Oh, after 9:30, it's a bit
Yeah.
difficult. Okay, fine, not an issue. We'll continue with the same time.
Or is it possible to switch to like around between 8 to 9 or 7:30 to 8:30, something like that?
No, because I need to rush to office, right?
Oh,
That
okay,
is,
okay, okay.
if we
Yeah.
want it a bit earlier, like 6:30, then also it will be fine for me.
Oh, okay. That would be little difficult for me.
Yeah, not an issue. We'll have the same time tomorrow.
Yeah, sure, fine.
Yeah, thank you.
Yep, fine.